Given the parabola defined by y equals -2 times x plus 4 times x minus 4, find the following information. The first thing we want to look at is whether the orientation of the parabola opens up or opens down. And the way that we're going to figure that out is by looking at the equation. Now, this is given to us in factored form. Remember, factored form looks like y equals a times x minus p times x minus q. So that's factored form, and the thing that we are going to look at is the a value. So in this case, the a value is -2. Because it's negative, that tells us that it's going to open downwards. So that is the correct answer for this first part of the question. Now we want to look at the vertex, the x-intercepts, and the y-intercept. Before I do the vertex, I'm going to find the x-intercepts because I think those are a little bit easier to find. So whenever we have factored form, the x-intercepts are going to be p, 0 and q, 0. And the reason that is because if we set our equation equal to 0, so if we have 0 equals -2 times x plus 4 times x minus 4, if I'm solving for x, I can divide both sides by -2. And so we get 0 equals x plus 4 times x minus 4. And then here we can use the zero product principle, which tells us that if we're multiplying two numbers together, then one or both of the numbers have to be 0. So we can take each of the factors and set them equal to 0. And if we do that, we get x equals -4 and x equals +4. So what that tells us is that our x-intercepts are 4, 0 and -4, 0. Now, let's do the y-intercept. We know the y-intercept is going to be 0, something, and there can only be one y-intercept because this is a function. If there were two y-intercepts, then it would not pass the vertical line test. So what we need to do is we need to plug in 0 in for x, and we get y equals -2 times 4 times -4. And -2 times 4 is -8, and -8 times -4 ends up being 32. So our y-intercept is going to be 0, 32. Now lastly, we can find the vertex. So I'm going to do some erasing here. If I were to sketch a very quick graph of this, we know that it's opening downwards, and we know that there is an x-intercept at -4, 0, and there's one at 4, 0. And we know that the y-intercept is at 0, 32. I didn't leave enough space up here, but just pretend this y value here is 32, so it's going to look something like that. Now, this is an interesting case because the vertex always falls halfway between the x-intercepts. And so one way that you could think about it is you could add 4 and -4 and then divide that value by 2. And so 4 plus -4 is 0, divided by 2, which is 0. So this is an interesting case where the y-intercept is actually the vertex because it's halfway between the x-intercepts. And so the vertex here is also going to be 0, 32.